Thank you, Maria. So, as I said, we are recording this meeting. A lot of people ask for that particular topic and are not able to join, and we have very interesting speakers. So let me start and officially welcome everyone. And thank you for joining for today's webinar, Revolution in Materials for Aerospace and Defense. I actually should probably say and beyond. For those who don't know me, my name is Kasia Piquet, and I'm CEO of Canadian Energy Ventures and also former Deputy Minister of Environment and Protected Area in this province, Alberta, Canada. I also want to introduce my Chief Operating Officer, Maria. You heard her saying she's taking care of logistics, and if you have even questions afterwards, please reach out to her. You would receive invitations from her as well. I also have with me today Dr. Andrzej Czulak. He's head of research and development of Polish cluster of composite technologies. And he will talk about more of a technical application of carbon composites, highlighted their role in energy transition and defense. And I also have Captain Sergei Kuziera all the way from Kiev, and he might be in transit speaking to us, but obviously he's fighting for democracy. Thank you, Sergei. And he's leading a technology innovation for Ukrainian armed forces. And he's going to tell us how the modern war is being fought. So I think it's super interesting. So let me first set a bit of a stage, tell you a little bit about history of carbon fiber, and then I'm gonna turn over to Andrzej. And Andrzej, if you like, you will have opportunity to tell us more about yourself, same with Sergey. So let's start. So let me give you a few key facts because I found them quite interesting. So carbon fiber technology is new, but not so new. So modern carbon fiber was developed in 1960s, so quite a while ago, by researchers at Royal Aircraft Establishment in United Kingdom, and then United States companies start working on that. So it took quite a while to develop those technologies. So I'm looking into Andrzej to tell us more about that. One thing I asked Andrzej, we are sitting in Alberta, the kingdom of oil sands, heavy oil, and the carbon fiber extracted from oil sands has got different properties. It's more flexible seams. And I have to also say one more thing. And I met Andrzej for the first time a year ago when he came to Canada for Hydrogen Convention as a part of the President of Poland delegation. They have toured Alberta Innovates. We also in Alberta obviously are working on this very interesting product. The MOU was signed and Andrzej is continuing the work. One thing I will also say, which I find fascinating, carbon fiber is 5 times stronger than steel, yet way lighter. So you see all the natural application for aerospace and potentially defense. And even over time, in everyday, I'm sure there are different uses for that, but let's focus on this one. So I mentioned oil sands. So Alberta has pioneer research in converting oil sands byproduct, especially asphaltene, into high-performance carbon fiber. So, but today we will be focusing on, as I said, energy transition, defense. Andrzej, over to you if you want to say a little bit more about the properties and about yourself, go for it.
Okay, Kasia, thank you very much for the introduction. One more time, my name is Andrzej Czulak, and I am the president of the Polish cluster of the composite technology. But from the background, I developed exactly using the carbon fibers, the vessels and tanks for the hydrogen. That's mean from the beginning, I had really huge contacts with the properties of the carbon fibers. But today I have very short presentation. Sorry, I forgot. I am also the president of Małopolska Center for Innovative Technology for Transport and storage of the hydrogen. That's mean this is exactly what is my topic of my development. This is the creation of the structure with very huge strength, especially for the energy transition and dedicated for the storage and transport of the hydrogen. But my presentation is about the carbon fiber. To the introduction of the Kasia, probably I will not present whole presentation because she said everything about the carbon fibers. But the carbon fibers, this is really key material in the modern composites. Oh, I need. And what is carbon fiber? Carbon fiber, how I said, this is key material in modern engineering. Why? Because it's light, strong, and heat resistant. That's why the carbon fibers are used in many applications, from aircraft, airplanes to the sport equipment. And what is important, carbon fibers is very thin, made mostly of the carbon atoms. And the carbon is much more thinner than human hair. On the right side of the slide, you can see the comparison between the human hair and carbon fiber. And the very thin carbon fiber is very stronger and stiffer than human, of course, hair. And you can also imagine the carbon fiber give the opportunity for the design. That is very soft, I will say, in the matrix, and that's why the engineers have possibility to design or freedom of design of different elements. But about the history of the carbon fibers, Kasia said something, but I will explain why carbon fibers are very expensive. Because carbon fiber production involves several steps. And the first step, this is the stabilization of polyacrylonitrile, and is over 50 hours in the temperature over 200 Celsius degree. Then the next step is the carbonization. The carbonization remove non-carbon elements from the carbon fibers, and the process is realized in the temperature over 1000 Celsius degree. And last step, very expensive also, this is the graphitization, the final heat treatment at the temperature over 300 Celsius degree, increase the carbon content and of course stiffness. And now the key properties. The key properties of the carbon fibers, this is the strength, tensile strength, that's mean in direction of the fiber is minimum 4000 megapascals, but it's possible also to obtain on the market the carbon fibers with the tensile strength over 6000 megapascals. That means they are the best steel. They have tensile strength in area of the zone 1000 megapascal. That means the carbon fibers, they are 4 times, 5 times, 6 times stiffer than steel. Very high modulus, Young modulus. This is up to 700 gigapascal, of course, after the graphitization. And of course, the graphitization and the process bring more cost for the production of the carbon fibers. That's why the carbon fibers is also expensive now. Low density. This is 75 gram per cubic centimeter, and excellent thermal resistance. It means the carbon fibers after special treatment can be used in the temperature over 3000 Celsius degree. Chemical resistance. Carbon fiber are unaffected by many corrosive substance and good electrical conductivity. That's why Edison, in the development of the carbon fibers, use the carbon fibers as a glowing material for lighting bubbles. But the carbon fibers have also some limitations, some disadvantages. And first is the low impact resistance and the sensitivity to oxidation, especially in the high temperature and in oxygen-rich environments. Now, the application. I think the composite carbon fiber reinforcement composite, they are almost everywhere, but the most industry where we're using the carbon fibers, this is aerospace and aviation. For example, in aircraft structure. On the left side, you can see Airbus A350. In this aircraft structure is over 22% of the composite materials, especially carbon fiber reinforcement polymers, using for the creation of the aircraft structure. For the turbine blades, heat shields. Automotive industry. In automotive industry, the carbon fibers are using especially or are predestinated for the sport car bodies. On the right side, you can see some picture of the carbon car, but almost in every supercars or so-called supercars or sport cars, the all element are produced from the carbon fibers. Sport equipment. Now, tennis rackets, bikes, skis, fishing rods, they are producing from the carbon fibers. Why? Because they are very light and very stiff. In construction industry, structural reinforcement, composite panels. And in electronics, because this is the conductive material, they are all using for electromagnetical interference shielding. But already we have also many applications in defense. That's mean, first of all, carbon fiber is used in composite or in production of the composite armor used in military vehicle and ballistic helmets, but also for the West and for the other personal shields. And this is very good experience also in the companies from my cluster. Already many companies using carbon fibers for the production of the drones, so-called UAVs, because they are light or lightweight, and the lightweight extend the range of the drones and of course the small aircraft, missile and rocket components, especially parts exposed to the extreme heat and the stress. The carbon fibers is also used for the electromagnetic shielding system. That means carbon fibers conductivity helps protect sensitive military equipment from the electromagnetical interference. And of course, last but not least, lightweight personal weapon system, because any soldier needs to take many devices with him for the fight. That's mean if we can reduce the weight of some elements, the mobility of the soldier will be higher. And overview about the composite market. On the left side, you can see volume of the composite materials used in different industry. The GAC Composite magazine calculated how many composite materials is already used in different industry, and total of the composite materials is between 14 and 16 megatons. Megatons, that's mean million of the tons. And of course, mostly the composite materials, they going into the construction, 26%, transportation, 26%, electric and electronics, 16%, energy, 15%, consumer goods, 7%, and aerospace less than 1%, but together with the other industry which have name others, this is between 12 and 13%. But on the right side, you can exactly see for what kind of industry, what kind of product will be used the carbon fibers. And for the construction, mostly is used glass fiber reinforced plastic, but in transportation, in the automotive and the road is mostly used the carbon fibers. In electrical and electronics also, this is not 100%, but some part of the elements for electrical electronics devices or industry is also used the carbon fiber. The very important industry is renewable energy. The name of this segment is the energy and renewable energy, because this is they are the wind power station blades, which are mostly made of the especially modern blades are made of the carbon fibers, because each company will have the bigger or longer the wind power station blades. That means they are using already carbon fibers. And the second part of the energy is oil and gas. And in the frame of oil and gas, we have pipes and tanks. And especially for the hydrogen, for the storage and transportation of the hydrogen or transfer of the hydrogen, today we're using the carbon fibers for the production of the pipes and tanks or vessels. The next design or consumer goods, mostly carbon fibers is used in design. And in the consumer goods, in sport, in recreation or hobby, the almost 100% elements which are produced for the sports and hobby used the carbon fibers. For example, bicycle frames, the small sports boats, similar in marine, because many yachts are produced in the form or using the glass fiber, but the sport yacht, they are almost created with the carbon fibers. And the last part where is almost used the only carbon fibers, this is the aerospace, defense and security, medical and prosthetics. They are area where the companies which producing the elements for this industry using only the carbon fibers. And this is my last slide. And the slide show why the carbon fiber market growth. And here I will to present some drivers for the market growth. And first of all, the carbon fibers. This is a very lightweight material, and the carbon fibers strength to weight ratio is the ideal for the aerospace and for the automotive and for any elements which are move, which can exactly improve the performance and efficiency. For example, fuel efficiency, because if we reduce the weight of the transported element, we reduce the consumption of the fuel, and also we reduce emission. The next driver is the hydrogen application. How I said already, especially in Europe, this is very hot topic, the using of the hydrogen for the energy transition, and for the storage and transportation of the hydrogen, we need the composite or carbon fiber reinforced tanks and the pipes. Wind energy. This is the same approach. Reduction of the weight of the wind blades. They bring more efficiency for the production of the energy using the wind power station. Last but not least is the cost reduction. And already the production of the hydrogen, production of the carbon fibers, it is cheaper and cheaper. And here I see huge possibility using exactly the technology which is developed in Canada, especially in Edmonton. This is the production of the carbon fibers with the Edmonton oil sands. And with this process, we heard about it, that this process can be cheaper than production in the classical method. And the last picture on the right side of my slide is projected market growth for the carbon fibers in defense. And the size of the market in 2024 or carbon fiber market in defense was 2.65 billions of US dollar. But during the situation in the world, the CAGR for each year is projected on the level 6.5%. That's meaning 2029, the size of the market should be 3.65 billion of US. And of course, the growth drivers, this is the modernization of military equipment used especially in the military vehicles, but also development of UAVs, that's mean drones. Thank you very much for your attention, and of course,
Andrzej, thank you. And I personally have a questions, and you see their incoming question in the chat box, but we will hold them. And as I said, we have another guest speaker, Sergey Kuziara. As I said, Sergey is on the road, but so he will be speaking to us with his phone. Sergey, are you on? I just want to make sure that we have him online with us.
Should I stop sharing?
Yes,
no,
yes. So
okay.
Before you start saying, let me just start by saying one thing. I would like if Sergey introduced himself a little bit better. His background is actually mining engineering. He's an engineer by trade. Right now, as I said, he is in charge pretty much of innovation and technology in Ukrainian army. But here's the thing, which is very important for everyone to consider. Really, Ukrainian army, and there's another one which we might not want to talk to, knows really how to fight the modern time war and have experience with it. Because as I was explained by Sergey, the other wars who are in the Middle East, they look very differently than this one. So Sergey, over to you.
Yeah, good morning and day for everybody, depending on your location. I heard the presentation of Angie, and I completely agree that this sphere is rapidly growing. And for your understanding, we have an absolutely different modern combat field. The tanks, which was used before, and it was a weapon of victory, practically are not used in the modern warfare. For example, the Abrams tanks we get from US, and it was used at the beginning of the war in the Ukraine, practically all is out of order because of the simple drones, which costs less than $500 per one drone. The land air and the marine use, we are particularly beat Russians only with the army of drones. In the beginning of the war, the Russian used 10 times more artillery shots than we does. Right now, we are actually using the same amount of drones, and we are holding the front line practically 90% on the usage of different drones, mostly air, the small ones, but also we are using a lot of ground drones. We are using from the, I told Pesha yesterday that we are using the even dogs, so-called dog drones. We are using them not so widely, but it's very effective. I wanted to show you the picture, but it's classified, but you understand what I'm talking about. Then we are using the small drones with the weapon platforms for actually combat use. And with the use of such an AI intelligence, it's very effective. So the soldiers are right now used only when it's needed to clear the field after the usage of drones. In the line of 20 kilometers, from 10 kilometers from each side, it's a war of the artificial intelligence, drones, and operators. Operators can sit anywhere. So the times changed, the war changed completely. We don't even understand the depth of this change. About the marine drones, they are completely made of carbon fiber. And there are no Russian ships in the Black Sea because of the small boats, 10 meters long, who carries from 2 to 4 missiles or torpedoes. We cleaned all the Black Sea. We sinked the flagman of the Russian fleet, Moskva. And actually, we did it with no fleet who belongs to Ukraine. So you have to understand the difference in the warfare. The same practically situation in the air. We are not using only the FPV drones or the bombers. We are using the deep strikes. And previously, the major material for the all missiles produced in the last 50 years was either metal or titanium. Either steel or titanium, sorry. Right now, we are using the deep strikes with the depth of 1,500 kilometers up to 2,000 kilometers right now, and we're developing rapidly the 2,500 kilometers. It's also so-called semi-drones. It's not the clear missile. It's with a jet engine, but it uses the principle of the drone. So with all subsonic speeds, we are using only carbon fiber for it. One more application is the air defense. Air defense, the all targets which are subsonic, they're shut down 50% by the small special drones for air defense, and they're even using the old devices, not devices, the missile devices like OSA, for example, Tunguska, and we change the rocket for the drones in these applications. It has a speed for 350 kilometers, and it's self-guided, and it's also made completely from carbon fiber because of the weight of the durability. And in major usage for the military, right now, we are not looking for the usage for a long period of time. We need to deliver the warhead once. So in this case, the titanium is very expensive. The special steels are also, and the carbon fiber with its lightness and durability is the best material ever made. I think that in the next 5 years, the usage for the defense purposes of carbon fiber will rise dramatically. So in times, not in percent. And actually, I'm dealing right now with the Defense Innovations Unit of Ukrainian Armed Forces. And if we will take 100% of the projects we are in right now, in 90% of it, the carbon fiber is used. It's all from me for now.
This is very interesting, Sergey. I want to also ask you a question because we talked offline before the call, and I understand you are coming to Canada because right now, for everyone who's listening, Sergey, it's in Kiev, right? Are you in Ukraine? Exactly where the action goes. And before I ask you about your Canadian trip, I just want to make one comment because yesterday, I think most of us watched Mark Carney meeting with President Trump. Of some of us for sure did, and everything is about military and increasing spending for military. So what I'm hearing you saying, modern warfare will be embracing carbon fiber to a larger degree, Sergey.
Yeah, absolutely. In many times.
Okay. Perfecto. So I want you to talk to us a little bit because I learned from you about CANSEC 2025. I wasn't really engaged in the military before. So what is that conference and why are you coming?
Because we need to search the new technology, the new implementations, and we are actually ready to share our experience. So we have a unique experience in the modern military warfare, and actually the Canadian companies are interested in it, and we are interested in also implementation of new technologies. For example, there is a company, Landing Zone, they're inviting us to their stand. We spoke with them before. They're using the small drones with aerostats, and they're also using the carbon fiber drones, actually, as an example. And we are open to share our experience, and I think that we also will be very useful for the Canadian producers.
So for everyone who don't know, so I quickly look it up. It's a aerospace and defense conference, and it's in Ottawa at the end of May, I think 28, 29 of May. So I have another question, Sergey, because that's a quite ways to travel. Is it the Ukrainian government paying for those trips? I have to ask, maybe.
No, unfortunately not.
So
unfortunately not.
So you are probably looking for support from companies who are exhibiting.
If we can get it, it will be very useful for us. So because a lot of stuff we are doing for our own expense.
Wow, thank you for doing that, and call of action to anyone who is listening now or maybe as a recording. I have before I went to the questions, and I think we have some in the chat box. I also want to ask Andrzej, because you didn't only work in Poland. You spent tons of time in Germany and in overall Poland. What is demand? Where are you buying the carbon fiber and how much and from where? And what are you paying? Let's get into practical details.
Okay, if we're talking about Poland, now I am in Poland, and Poland, we don't have producer of carbon fibers. In Poland, it's
Rywany się
mean
skryli, że się zbudził.
it's mean
Sergey, you might want to mute your mic.
That's mean the companies from our cluster, they need to buy the carbon fibers from outside, from outboard. And after our analysis, this is exactly the background for our discussion. The 90% of carbon fibers which we're using in Poland, they're coming from China. Because already after 20 years, before 20 years, the China doesn't have experience with the carbon fiber. Now, the experience of a Chinese producer of the carbon fibers is very, very high. And of course, the other countries, they have problem because the China using the dumping prices for the carbon fibers, and carbon fibers is already quite cheap in China. That's mean 1 kilo of the roving of the carbon fibers cost $8 US dollars. It's mean this is quite cheap. When I started my journey with the composite material in Germany, exactly because I make my PhD on the Technical University in Dresden. This is the center of the composite materials, advanced materials in Germany. And I was involved exactly. My PhD was about the development technology for the production of carbon fiber reinforced tanks. The 1 kilo of the carbon fibers in 2000, there was between 100 and 200 US dollars. That's mean that was quite expensive. Now the cost of the 1 kilo of the carbon fiber is less than 10 US dollars. That's mean the price is strong reduced, but still 20 times, I think, higher than glass fiber. And here we have also huge opportunity. I hope in the collaboration with the Canada, maybe we can obtain the carbon fiber cheaper than from China with the better quality. And if we're talking about the other countries in Europe, the Germany, they have own production stand or production facility in Germany, but production carbon fibers in Germany already is no, from the economical point of view, not so very good solution, because the energy in Germany is quite expensive, and how you saw in my presentation, the energy for the production of the carbon fibers playing main role, and the United Kingdom have also the devices for production of the carbon fibers. Of course, there are some located in US. The bigger producer of the high quality carbon fibers is Japan. But no, if we're talking about the amount of the production of the carbon fibers, on the first place are located China, or is located China. And what could be dangerous also for all of us in Europe, because it's very difficult to buy carbon fibers. But already Russia built also own fabric for the production of the carbon fibers. This
If you
is
allow
I
me,
was
if you
Yeah,
allow
go
me,
ahead.
I will add a couple of words. I am deeply involved in NATO cooperation from Ukrainian side. And for the NATO countries, there is different standards for the China components. And right now, most of the countries are entering the new stage, and they're implementing the zero China components in the NATO weapons and so on. So, for example, the Danish Ministry of Defense already put the zero tolerance for it. So, for NATO countries, for the military use, the price is not so important. They have to be absolutely sure that their suppliers are reliable, and the China is not the reliable supplier. So that's why definitely the production of the carbon fiber materials in Europe will grow.
That's a very valuable point. So we have a real opportunity. As you know, Andrzej, we tour Alberta Innovates, and we are getting very close to the production. And actually, I'm gonna interrupt because I see someone online who is has got more experience that I am being around in energy business, and it's involved in some of the early production and works with Alberta Innovate. That's Mr. Alfred Fisher. Fisher, why don't you tell us a little bit more what you are working on? Because it is about carbon fiber and bringing to the production. And the way we met when I was still a deputy minister, it was with Alberta Innovates. You are on mute, Alfred.
Thanks, Kasia. Can you hear me now? I've been working with on the oil sands since 1974, and as you know, the Canadian oil sands is probably the largest recoverable reservoir of carbon in the world. And we are doing a lot of work in what now they used to be called bitumen beyond combustion, Kasia. It's now being renamed bitumen advanced materials, and the key is carbon fibers, asphalt for the world, and other products. So one of the projects we've worked on, we've been trying to create asphalt for paving materials around the world and try to address the world asphalt shortage. But the same material that we're using for asphalt, we make asphalt oil. We're just doing a pilot test along with our First Nations to produce a bunch of asphalt oil. And that asphalt oil can be used as a precursor to carbon fiber. As you pointed out, carbon fiber needs a lot of processing. We've been working with a company called Soltec in the US, and they turn out to be a subsidiary of Toray, which is the largest composite fiber manufacturer in the world from Japan. But Canada, we do have the advantage of probably the largest resource of carbon in the world that's accessible today. And so we are very interested in being able to export carbon and also work with, so that's why the Americans and Japanese are coming here for the source material. We could load that stuff out and get you. The other company I'm working, carbon fiber is very interesting, but as you pointed out, carbon fiber has one deficiency, it's very brittle, and when you hit it with something, it shatters. So I'm working with another company called Inca, which is composites for the aerospace, for vehicles, got contracts with Toyota. And we're using plastic composites and carbon fibers mixed with hemp, with the plant. And now, of course, Ukraine and Poland have the ability to grow a lot of hemp as fibers. The advantage is it's light, cheap, and it's being used now as the replacement for wind turbine blades. So we're building a 500,000 square foot or be 50,000 square meter facility in Vegreville right now. We're starting construction on that, and we'll be a major producer of composites that way. And the company has not looked into combining carbon fiber with resins, but we're using biomaterials such as hemp to produce carbon fiber, and it's a lot cheaper than, the other point you made is, we can use that stuff for building composites. And we're busy doing that. But if you need any asphalt, Alberta has the largest reservoir of asphaltenes and asphalt carbon in the world. And we are currently working on doing two things: proving that the Athabasca bitumen is the best bitumen and carbon in the world. And the second thing is solidifying it so we can transport that stuff to anywhere in the world using bulk ships. And one of the things that I've seen from Dr. Zhao in the presentations on carbon fiber, if a carbon fiber builds out completely, it's estimated that we will use 1.5 million barrels a day of Athabasca production, the bitumen production, just to service the carbon fiber industry in the world. Obviously, that's not going to be used in Canada by that amount, but there'd be a demand for it. So it's a major demand for the Canadian oil sands and in the future, not as much as the asphalt and other uses, but so that's what I'm working on. If anybody's interested in following up on that, I can send you information on Inca. I can send you information on the whole carbon fiber in asphalt production. I've been working on it since 1974. So
this is all interesting, and it sounds like there's lots of different technologies and different group of people working on it. I think that even international cooperation, if may I say, will be super important. And as Sergey mentioned, NATO specifically says, no China, please, let's produce this somewhere else.
Yeah.
So I do think there's a real opportunity for everyone. And everyone who knows me, I strongly support specifically Polish, Canadian, and European cooperation. So we'll see where that goes. Gord, you had an interesting questions, and I don't know who can take this, possibly Andrzej. So Gord, maybe you can introduce yourself and ask a question if you wish. I don't see everyone here, so why, and some people left, so I'm gonna ask Gord question. He was asking about application of carbon fiber in agriculture. So I wonder, Andrzej, if you can take this.
Yes, of course. And I am not huge experience with the agriculture and application for the agriculture. From my knowledge, there's some companies develop some harvest or elements for the harvesting robots for agriculture and also for the observation drones. That's mean they are exactly a similar solution like for defense, I will say. This is exactly for the drones and for harvester robot. This application.
So I think there are applications everywhere, to be honest. So there is going to be last questions. This question is from me, and I think if there is no further question, we will wrap it up. I promise to keep it to 15 minutes. But you're a scientist. You were in the cluster with lots of more scientists. So what are the most important emerging trends when it comes to carbon fiber? What shall we focus on really?
I think the previous speaker say something about the trends, but exactly from my point of view, this is bio-based components. Bio-based components, this is the future of the components. But if we're talking about on your picture which you presented, there was the one drone, military drone. Can you one more time show this drone? Only this fly-eye picture of this drone. This drone is quite large. The size of the width of this drone is more than 2.5 meters. This is really huge device. And composite structure, which you can see this gray structure is made, of course, of the carbon fibers. The weight is 2.5 kilo. That's mean if we will create such drone from the hand, which the tensile strength of the hand or the flax is, I will say, 4 times, 5 times less than carbon fibers, such composite structure will have weight over 10 kilo. That's mean, of course, for one-way drones, for one-way UAVs, of course, no problem. But if we're talking about the very expensive devices, which should be created for a long distance, only solution is carbon fibers. When we're talking about the trends, from my point of view, the very important point, this is recycling of the composite materials, especially if we're talking, for example, about the drones. How many drones using the Ukraine per year? Sergey, can you answer? Because
yes, I can't answer you how many we are using per year. I can answer you that we are using thousands of them per day. So for a year, we are using more than 1 million, definitely. And the base for it, even for the smaller one, are the carbon fiber frame.
And from my point of view, exactly the trends for the composite materials, especially for the carbon fiber solution, is find the way for the recycling of the carbon fibers. Today we're talking about application for defense, but if in the future we will have the hydrogen power cars, after each accident is necessary to create the recycling process for the vessels, for the hydrogen vessels, for the connectors, and so on. That means the next trend, from my point of view, this is the recycling of the composite materials. But also very important trend is development of the smart structure, because the composite materials, they are materials which can be smart. For example, during the development of the composite material, you can integrate inside of the structure, for example, the sensors. For example, structural health monitoring. It was also a part of my dissertation. That means this is also the trend, the creation of the carbon fiber structure, but with the integration of the sensor. And I think also is important today the automatization of the production of the composite materials, because everywhere the labor cost and the energy cost going up. That's mean the automatization of the production of the composite elements. This is the future of the composite world or industry.
Thank you so much. And we are over the time, but this is a very interesting and very, very good commercial idea. And again, I cannot stress enough about the importance of international cooperation on that. And let's hope that will continue. So, Maria, let's maybe send this even recording to everyone who participated. It's going to be on our website. And obviously, let's continue the conversation. So thank you very much, Andrzej from Krakow, one of the most beautiful city in Poland, although I'm from Warsaw, so we can live at that, but I have to give that to Krakow. And Sergey, thank you for calling all the way from
Thank you.
Kiev. So thank you everyone for listening and asking questions. Thank you.
Thank you. Bye.
Thank you very much. Bye-bye.
Thank
There
you.
was really big pleasure to present the presentation for you. Bye-bye.
Thanks a lot. Have a great afternoon.